Hi, students and friends. This is your host and teacher, Sayyid Ayazuddin Haider. You're watching Learn and Teach by Sir Ayaz. Most of my students want me to solve O-level past papers of 5070, and they want me to solve 2015. So this time I have selected 5070 2015, and the variant is 22. It's May-June 2015. It's a 1 hour, 30 minutes paper. It's structured questions or theory. There are two sections in this paper. Section 1, Section A is of 45 marks, and Section B is of 30 marks. In Section B, there is a choice of solving any three questions from the four questions. The electronic calculators may be used. A copy of the periodic table is printed on page 20. So let's start the paper. Here's section A. Answer all the questions in this section in the spaces provided. The total mark for this section is 45. I have already mentioned top. A1. Choose from the following compounds to answer the questions opposite. So we have these compounds A, B, C, D, E, F. So for convenience, I'm going to write their name. So we have three carbons. This carboxylic acid family. The name of this A is propanoic acid. B, there are four carbon atoms. The functional group is OH, which means it's an alcohol. It's a butanol. According to current syllabus, they will call it butane dash 1-ol. C is chlorofluorocarbons. You can write CFC, chlorofluorocarbon, or dichlorotetrafluorocarbon. What about D? D is alkane. There isn't any double bond. All are single bonds. So hydrocarbon 1, 2, 3, 4, 5, 6. So it's hexane. E. What is E? E is dichloroethane. This one is also ethane, usually known as CFC. F. Now this one is ester group attached to this, and this part is the alkyl group, and this one is the alkanoid group. We have three carbon atoms, so it must be propyl, and two carbon ethanoid, propyl ethanoid. We also have G and H. What is G? The two carbon atoms and OH as the functional group. This is ethanol. What about H? H is again carboxylic acid. Sorry, it's also an ester, just like F. Alkyl group is of two carbons, so it must be ethyl. What about alkanoid? There are three carbon, 1, 2, 3. Ethyl propanoid. Now you can solve the questions. Each compound can be used once, more than once, or not at all. A. Give the letter of the compound which is a CFC. C must be CFC. This is C. So you write the letter C. What about 2 is propanoic acid. So do we have propanoic acid? Yes, A is propanoic acid. Here it is. So you write A here. Number 3 is propyl ethanoate. Where is propyl ethanoate? This is propyl ethanoate. It's F. So you write F here. 4 can be oxidized to ethanoic acid. It must be alcohol with 2 carbon atoms. So it must be G. So you write G here. B, give the letters of 2 compounds that react together to make an ester. You can have alcohol, any alcohol, and carboxylic acid. So for alcohols, you can have either B or G. So what about carboxylic acid? We have A only. So B or G and A. B or G and A. Moving to next question. A2. Hydrogen reacts with halogens to form hydrogen halides. A. Predict which halogen reacts most violently with hydrogen. These are the halogens, group 7 elements. We have fluorine, chlorine, bromine, iodine, and acetylene. So fluorine is the most reactive one. So it must be fluorine, which will react most violently with hydrogen. Because in this group, as you go down the group, the reactivity decreases. So fluorine must be highly reactive. It will react violently. B, the reaction between hydrogen and chlorine is exothermic. This is the reaction. H2G plus Cl2G gives 2HClG. Delta H is minus 185 kilojoule per mole. G means gas state, and this is the delta H, which is enthalpy change. Number 1, explain in terms of bond breaking and bond forming why this reaction is exothermic. So we know that bond breaking is endothermic or takes in energy. Bond breaking is endothermic or takes in energy, while bond making is exothermic. Or releases energy. So the reaction is exothermic, which means more energy released than absorbed. When 1 mole of chlorine molecules reacts, 185 kilojoule of energy is released. Calculate the amount of energy released when 106.5 gram of chlorine reacts. 1 mole of chlorine. You see here 1 mole of chlorine. So I will write here 1 mole of chlorine. So 1 mole of chlorine releasing minus 185 kilojoule per mole of energy. You have two options. Either you will convert the moles into grams or gram into moles. In both the cases, you need mR of chlorine because we have Cl2. So I must say mR of Cl2. So for this, you need AR of Cl. Where is Cl? Here is Cl. AR is 35.5. So MR of Cl2, 2 multiplied by 35.5, it must be 71. 35.5 multiplied by 2 gives 71. So 71 is the MR. In order to convert these grams of chlorine into moles, you need to divide the mass by MR. So number of moles of Cl2 is equal to 106.5 divided by 71. So these are the moles, 1.5. So you can write 1 mole of Cl2 releases, as it is exothermic, so I will write releases 185 kilojoule. Therefore, 1.5 mole of Cl2 releases X kilojoule. So you do the cross, 1 multiplied by X is equal to 1.5 multiplied by 185. 1.5 multiplied by 185. 277.5. 277.5 kilojoule of energy is released. C. Hydrogen reacts with iodine in a reversible reaction. This reaction reaches an equilibrium if carried out in a closed system. Here's the reaction: H2G plus I2G, reversible sign, 2HIG. Delta H is plus 53 kilojoule per mole. Plus means it's endothermic. The forward direction is endothermic. So if this side is endothermic, this is endothermic. So backward direction must be exothermic. So you write minus for this side, delta H. The reaction is studied at a temperature of 400 degrees centigrade. Describe and explain what happens to the position of equilibrium if the pressure is increased. Now you are increasing the pressure at a fixed temperature, which is 400 degrees centigrade. They are not changing the temperature. What you are doing, you're just changing the pressure. Though changing the pressure, it will affect on the basis of number of moles or volume of gases on both sides of the equation. Remember, you have to consider the only gas state. You can't consider solid, liquid, or aqueous state in this case. So in this case, what will happen? There won't be any effect. The reason is that on the reactant side, you have 1 plus 1, 2 moles or 2 volume, and product side again you are having 2 moles. So there won't be any effect. You can write no change because number of moles or molecules or volumes of gases are same on both sides of the equation. Okay, next part. The reaction is studied at 25 atmospheres pressure. This time they are maintaining the pressure. What they ask you, describe and explain what happens to the position of equilibrium if the temperature is decreased. Now, definitely the equilibrium will shift to the side which is exothermic. So backward direction is exothermic. Equilibrium will shift toward left hand side, left hand or reactant side. Furthermore, you have to write forward reaction is endothermic or backward is exothermic. Hydrogen iodide dissolves in water to form hydroiodic acid, HI aqueous. Hydroiodic acid is a strong acid. Number one, write an equation to show the dissociation of hydroiodic acid. So the formula for HI is given, HI aqueous. And they are asking you to show the dissociation. Remember, you have to show this sign, only one direction sign. The reason is that they are saying it's a strong acid. For strong acids, we use this sign. For weak acids, we use reversible sign. The reason is that in weak acids, the molecules on the product side rejoin, combine to give the reactants again. So now I'm going to show the dissociation. You know, acids, they dissociate to give H positive ion. So I will write H positive aqueous plus I minus aqueous. Number two, hydroiodic acid reacts with calcium. Write the equation for this reaction. This reaction HI aqueous calcium solid. If you look at the periodic table, calcium is in group 2, which means a metal. What you will get when you react metal with acid? You will get metal salt plus hydrogen gas. So one of the product must be hydrogen gas, that is H2. What about the salt produced? Salt produced must be between calcium and iodine. Here's a periodic table. This is a calcium. Here's iodine. Here's iodine. It's in group 7. The valency for group 2 is +2. Group 7 is -1. So you need to work out the formula between these two. We have CaI. +2 is the valency for calcium, -1 for iodine. Ignoring their charges, subscripts will be swapped. So you'll get CaI2. Calcium iodide, CaI2. You must get calcium iodide, CaI2. Let's balance the equation. Equation is now balanced. Number 3, hydroiodic acid reacts with sodium carbonate. Write the ionic equation for this reaction. They are asking the reaction between hydroiodic acid, HI, must be aqueous, sodium carbonate. Sodium carbonate is also soluble in water. You can write aqueous plus the products when metal carbonate react with acid. This is acid plus metal carbonate. You will get 3 products. salt or metal salt plus carbon dioxide gas plus water. You know the formula for carbon dioxide and water, straight away write CO2. Gas, it must be in the gas state. Water, H2O, it must be in the liquid state. What about the salt produced? Salt produced must be between Na and I. Here is Na in group 1, I in group 7. Group 1 has valency of -1, +1, sorry. So +1, -1, which means if you'll predict the formula between these two, what you'll get? Na, I, +1, -1, ignore their charges. So the ratio becomes same. So you must get NaI must be soluble. All these salts of group 1 are soluble. So let's balance the equation. 2NaI, 2HI. Check the balancing of the equation. Equation is balanced. Now, what is the rule for writing the ionic equation? Split up all the aqueous states. Only aqueous states. Leave these states as it is, gas state and liquid state. And split up these states. This one, this one, this one. So what we will get? We will get 2H positive aqueous plus 2I minus aqueous plus 2Na plus aqueous plus CO3 minus 2 aqueous gives 2Na plus aqueous plus 2I minus aqueous plus CO2 gas plus H2O liquid. Now spectator ions are common ions found on both sides of the equation. They will be cancelled out. So here we have spectator ions. All these spectator ions are cancelled out. So in the end, you'll be left with, I'm writing it here, 2H positive aqueous plus CO3 minus 2 aqueous gives CO2 gas plus H2O liquid. Moving to next question. A3, two isotopes of phosphorus are P31 and P32. A state one difference and one similarity between these two isotopes. Differences between these two. They must be having different number of neutrons or nucleon number or physical properties. Any one from different nucleon number, different number of neutrons or different physical properties. And this is due to the presence of different number of neutrons. You can mention the physical properties like melting point, boiling point, density, rate of diffusion. Similarity, now they are atoms of the same element. So they must have same proton number or number of protons. Number of electrons are also same. So due to this reason, they have same chemical properties. Same proton number. Same number of protons or same number of electrons or same chemical properties. B. Phosphorus forms simple molecules which have a relative molecular mass of 124. Suggest the formula of a phosphorus molecule. So MR of simple molecule of phosphorus is given. We don't know how many atoms are in this molecule with the molecular mass of 124. So I will write some mass. We'll do it here. Mass and number of atoms. So mass is 124 and number of atoms is X. We don't know. What about the AR of phosphorus? Here it's 31. So you write the mass of 31 is of one atom. So if the mass of one atom is 31, so X atoms have a mass of 124. So it becomes 31X is equal to 124, or X is equal to 124 by 31. X is equal to 124 by 31. Yeah, it's clear now. 124. So it must be 4. So formula must be P4. C. Phosphorus has a low melting point and does not conduct electricity. I won't explain why phosphorus has a low melting point. It's due to weak intermolecular forces. Weak intermolecular forces, and due to this reason, less amount of energy needed to break down the force. Explain why phosphorus does not conduct electricity. No, conduction of electricity is related to the presence of mobile electrons, mobile or free electrons. So you write phosphorus does not contain free or mobile electrons. You can even use a term like delocalized electrons or delocalized. Same meaning. Delocalized means free or mobile. Complete the table for P3 minus. 3 minus means it has gained 3 electrons. So the small number indicates the proton number, which means the number of proton must be 15 here. What about number of neutrons? In order to find the number of neutrons, you need to subtract 15 from 31. So I write 31 minus 15. And you will get 16. Now they are asking electronic configuration. Electronic configuration, it means distribution of electrons. distribution of electrons in different shells. So the number of electrons, first of all, you should know the number of electrons. 15 is the proton number, which means the number of electrons must be 15. But you see there's a 3 minus charge, which means this phosphorus atom must be having 3 extra electrons. So I will write 15 plus 3, which becomes 18. So I need to distribute the electrons, 18 electrons. So it must be 2, 8, 8. This must be the final answer. E phosphorus forms a compound called phosphine pH3. Draw the dot and cross diagram to show the bonding in a molecule of phosphine. Only draw the outer shell electrons. So I'm going to show the key here on the right hand side. We have P here, hydrogen here. For phosphorus, I'm using dot. For hydrogen, I'm using cross. The number of electrons in phosphorus as well as in hydrogen. Here's a periodic table. The number of electrons for phosphorus is 5. What about hydrogen? It must be 1. See the number 1 and 1, which means the proton number is 1 and it must be having 1 electron. So 5 electrons for phosphorus and 1 electron each for hydrogen. So we have 1 phosphorus atom. So in the middle, I'm going to place phosphorus, 3 hydrogen. We have 1 hydrogen, 2 and 3. Now let's place the electrons for each hydrogen. 1, 2, 3. Circle for each hydrogen atoms. What about the electrons for phosphorus? 1, 2, 3, 4, 5. This must be the final dot and cross diagram. F. Phosphine ignites in air to make water and phosphorus 5 oxide. Construct the equation for this reaction. Formula for phosphorus is P. And they are igniting in air, which means sorry, there's a mistake. Phosphine is pH3. pH3 is not phosphorus, phosphine is pH3 plus ignite in air, which means reacting with oxygen. Product is water and phosphorus 5 oxide. Water is H2. Phosphorus 5 oxide means the valency of phosphorus is 5 here. Valency, or you can say oxidation state. So let's predict the formula between phosphorus and oxygen for phosphorus 5 oxide. Oxygen is in group 6. Here's group 6. Oxygen group 6. So group 6, they are having valency of -2. So for oxygen, I'll write -2. For phosphorus, they have already mentioned it's +5. It's less electronegative than oxygen. It must be having +5. Ignore the charges. It become 5 and 2. These subscripts will be exchanged. Get what? P2O5, P2O5 plus P2O5. Now, if I will balance the equation, I will write 2 here before pH3 in order to balance phosphorus. What about hydrogen? Hydrogen becomes 6. So, which means I have to place 3 here. Hydrogen is balanced. What about oxygen? On the right hand side, you have oxygen 3 plus 5. It's 8. So, you have to write 4 here. It's balanced now. That's all for this video. Thanks for watching. Press like and share my videos. For more videos, subscribe to my channel and press the bell icon.